Hi, in this video we are going to see about cellular concepts and frequency reuse. A cellular network. This diagram shows a network which consists of different types of base stations and mobile users. Principles of cellular network. Underlying technology for mobile phones, personal communication systems, wireless networkings are evolved. Developed for a mobile array telephone. Replace high power transmitter and receiver systems into a low power one. Typically, a cellular network supports for 25 channels over 80 km. It uses low power for short range and requires more transmitters. The architecture of a cellular network system is shown in this figure. The three major subdivisions are mobile station, base station subsystem and network subsystems. Base station controller and base station transceivers are covered in this. For a cell, one base station transceiver is present. One BSC can control multiple BTS. It allocates radio channel among BTS and also it manages call handoffs between BTSs. It controls handset power levels. Mobile switching center connects to PSTN and switches calls between BSCs. It provides mobile registration location authentication. It contains equipment identity register. Cellular architecture. In home location register and visitor location register, it provides call routing and roaming. VLR, HLR and MSC's functions are generally in one equipment. Equipment identity register contains a list of all valid mobiles. Authentication service center stores the secret keys of all SIM cards. Each handset has an international mobile equipment identity number. Activity. Difference between two images. Cellular network organization. Multiple low power transmitters are in a base station. It requires 100 watts or less to operate. The area is divided into small cells. Each cell has own antenna and each with own range of frequencies, served by a base station and a transmitter receiver control unit. Adjacent cells on different frequencies is allocated to avoid crosstalks. Shape of a cell. With D cell has 4 neighbor at distance D and 4 at distance D. Better if all adjacent antennas equidistant simplifies choosing and switching to new antenna. For hexagon shape, it provides equidistance antennas. The radius defined as radius of circumcircle. Distance from center to vertex equal length of all sides. Distance between center of cell radius is denoted by R. It not always precises hexagons. Topographical limitations, local signal propagation conditions, local of antennas are present. Frequency reuse. Frequency reusing is the concept of using the same radio frequencies within a given area that are separated by considerable distance with minimal interference to establish communications. The benefits of frequency reuses are: it allows communication within cell on a given frequency. It limits escaping power to adjacent cells. It allows reuse of frequency in nearby cells. Uses same frequency for multiple conversations and it requires 10 to 15 frequencies per cell. Power of base transceiver control. It allows communication within cell on given frequencies. It limits escaping power to adjacent cells. It allows reuse of frequency in nearby cells. It uses same frequency for multiple conversations. N cells are using same number of frequencies and K total number of frequencies used in system. Each cell has K by N frequencies. This diagram shows the frequency reusing concept. Frequency reusing using 7 frequency allocations are shown in this block diagram. The reuse cluster. Each cell uses totally the different set of channels with the other in the same. Reuse distance. Minimum distance between two cells using same channel. Co-channel interference. Interference for satisfactory signal quality caused by transmissions of co-channel cells. D is the minimum distance between center of cells that use the same band of frequencies. R is the radius of a cell, and small d is the distance between center of adjacent cells, where d is equal to r into root 3. N is the number of cells in repetitious pattern. Each cell in pattern uses unique band of frequencies. Hexagonal cell pattern following values of n possible is given in this equation. An example of frequency reuse is shown in this figure. Assessment: what is a cell, what is frequency reuse or frequency planning, what is hard and soft handoff. Thank you.